Hi everyone, I'd like to tackle another example of trying to find limits algebraically. So you'll notice we're going to take the limit as w approaches -1 of 2w plus 1 over w squared plus 3w plus 2. You'll notice that we're working with a lot of fractions, and the reason for that is because fractions are when you get the discontinuities. When the bottom is 0, the function is undefined, and they're really interesting because depending on what's going on near that discontinuity, we could have asymptotic behavior, or it could be a removable discontinuity, a hole in the graph, in which case the limit will be really nice. So here's another one, and always your first step should be to just kind of investigate what's going on near -1. So on the top, if w is really near -1, then this is really near -2 plus 1, which is -1. So the top is getting really close to -1, whereas the bottom is getting really close to 1 minus 3 plus 2, which is 0. So there's definitely discontinuity, but because the top is not also 0, I would not expect this to be removable. I don't think I can use algebra to cancel out a factor. What's really happening here appears to be the asymptotic behavior. If you take a number really close to -1 and you divide it by a really, really tiny number, like 0.001, what you're going to get is a really big number. So this is headed off to plus or minus infinity. And the whole key to this is going to be, do both sides head the same direction? So at -1, we have some sort of vertical asymptote. And if it's doing something along these lines, then it's going to be a does not exist, because near w equals -1, one side's headed to negative infinity and one side's headed to positive infinity. That's no good. It could also be something more like this, where both sides head either to positive or negative infinity. In that case, the limit will exist. It will just be positive or negative infinity. So to figure this out, you can actually check a graph. You can plug in numbers really close but smaller than -1, and then really close but bigger than -1 to see what's happening. So here, I'm just going to check out a graph. I think seeing these things is always nice. So if you can do this algebraically, you should. I'll be expecting to see the work. But if you conclude that algebra isn't going to help you, it's fine to go to technology and say, let's see if I can figure out what exactly is going on. 3x plus 2. Okay, and then I'm just going to try Zoom Standard to get me started. I think that'll do it for me. Ooh, that's an interesting one. Okay, so I think what I'm seeing is there's two vertical asymptotes with this little tiny bit in the middle. Let me see if I can mess with my window a little bit. Let's let x's go from -3 to 2, and let's go -20 to 20 on our y. So I'm going to shrink the x's in a little and stretch the y's out so I can see more of that little u at the top. Yeah, there they are. So we could factor this to see as well. This is a w plus 2, w plus 1. So there are vertical asymptotes at -2 and at -1. We get this little chunk in the middle. So we're interested, let me check, we're interested in what's happening near -1. Hey, I did good drawing my first one. We're getting a positive infinity on the right and a negative infinity on the left. So this is going to be a does not exist. If both of them headed to positive infinity, so for example, 1 over x squared, that guy, both sides headed up to positive infinity, we would say the limit is positive infinity. As long as both sides are doing the same, you're fine. But if both sides are different, then you're in a little bit of trouble. All right, so make sure the first thing you do is check and see if it appears that you might have a removable discontinuity. If it doesn't, then algebra is not really very helpful.